Know that Earth and the rest of the planets rotate around the Sun. One trip around the Sun is equal to 1 year. The official name for this trip is called an orbit, and one complete Earth orbit, as we know, takes 365 days. Jupiter's orbit, for comparison, takes 12 Earth years. Jupiter's a lot further from the Sun than we are, so as you can imagine, it has a longer distance to travel. The Earth rotates around the Sun, but it also rotates around an internal axis. A great way to visualize this concept is to think about a top. Notice how each of these tops has a long end and a pointy end. Draw an imaginary line through both of these ends and you have an axis. The top will always rotate or spin around the same imaginary line. The same is true for the Earth. Earth always spins or rotates around the same imaginary line. However, Earth's axis isn't straight up and down like a top. It's angled at 23.5 degrees. At least it is right now. Over the course of about 40,000 years, this angle will cycle between 22.1 degrees and 24.5 degrees. You might have heard before that Earth's tilt is what allows our planet to have different seasons. If you're in the northern hemisphere, you'll have winter when it's cold, summer when it's hot, and spring and fall in between. With our current tilt of 23.5 degrees, these seasons are pretty mild. With a lower axial tilt of 22.1 degrees, they would be even more uniform. A larger tilt of 24.5 degrees would mean more extreme seasons. Let's take a look at why this is. Even though Earth's axis is tilted, the Sun's rays are still hitting our planet horizontally. Depending on what time of the year it is, i.e., what season it is, the tilt of the Earth will directly affect the amount of sunlight that different tropics will receive. And when I say tropics, I'm referring to either the Tropic of Cancer or the Tropic of Capricorn. The Tropic of Cancer is an imaginary line that circles the globe parallel to the equator at 23.5 degrees north latitude. And the Tropic of Capricorn is an imaginary line at 23.5 degrees south latitude. Okay, now that we know where these tropics are, we know that the Earth rotates around a tilted axis, and we know that it orbits around the Sun. Let's put all these together. We will go season by season, so let's start with spring first. Take a look at the horizontal rays coming in on the left side from the Sun. The rays are coming in horizontally, but because our planet is a globe, there is only one spot where these rays are hitting at a perpendicular angle. Looking at this image, can you tell where it is? If you said the equator, you're right. When the Sun's rays hit a line of latitude at a perpendicular angle, that is where the most direct sunlight is received. When rays hit at less than a 90-degree angle, the sunlight is spread over a much larger area, so heat is dispersed instead of concentrated. We've learned a lot from this image so far. In the springtime, the Sun's rays hit the equator at a perpendicular angle, meaning it receives the most direct, concentrated sunlight. The Tropic of Cancer and Tropic of Capricorn receive equal amounts of sunlight as each other, as do the Arctic Circle and Antarctic Circle. One thing I want to point out from this image is the amount of daylight that we experience in the springtime. Because Earth is tilted on its axis at this point, not tilted toward or away from the Sun, all areas of the globe will receive equal amounts of daylight and darkness, 12 hours of each. The first day of spring, as shown here, is called the vernal equinox, meaning equal daylight and darkness. As spring turns into summer, the days grow longer and the nights become shorter. When we talk about summer, we're going to refer to this as the Northern Hemisphere summer, since that is what the United States experiences. This is showing the first day of summer, which is called the summer solstice. The solstices represent the Earth at its closest or farthest from the Sun in its orbit. During the Northern Hemisphere's summer solstice, the Southern Hemisphere is experiencing its winter solstice. Take a look at Earth's axis now. we can see how it's sort of tilted toward the sun. Can you determine at which latitude the sun's rays are hitting our planet at a 90-degree angle? This time, it's the Tropic of Cancer. At the Tropic of Cancer during Northern Hemisphere summer, Earth receives the most direct concentrated sunlight. During North America's summer season, the increase in direct sunlight causes a rise in temperatures. More sunlight equals more heat. Now, take a look at the Antarctic Circle. Imagine the Earth spinning in this location around its axis. Are you able to visualize how this particular area of the globe is always in the shaded region? This means that many regions in the Antarctic Circle experience a polar night, which is when darkness lasts for more than 24 hours. During Northern Hemisphere summer, the Antarctic Circle receives the least amount of sunlight. Conversely, check out the Arctic Circle and visualize how, when the Earth rotates around its axis, it is always in the lit-up region. The Arctic Circle experiences a polar day during summer when the sun is above the horizon for more than 24 hours. In summertime, the Arctic Circle receives the most amount of sunlight. Now let's talk about fall. Looks the same as the vernal equinox, right? That's because this is the autumnal equinox. Again, the Earth is neither tilted toward or away from the sun, but more on its side, so all areas of the globe receive equal amounts of daylight and darkness. Once again, the equator receives the most direct, concentrated sunlight. Next up is wintertime, in particular the winter solstice. This is the same deal as summertime, except now the Earth is tilted away from the sun. Where are the sun's rays hitting at a perpendicular angle? This time, it's the Tropic of Capricorn, located at 23.5 degrees south. While the most concentrated direct sunlight is hitting the southern hemisphere, the northern hemisphere is experiencing the colder temperatures of its winter season as the southern hemisphere enjoys the warmth of summer. During North American winter, the Antarctic Circle gets their polar day, while the Arctic Circle experiences a polar night. One more thing to note about all these scenarios is that along the equator, it will always receive the same amount of daylight and darkness no matter what season it is. This is because of the equator's central location and equal distances from the North and South Pole. Once the Earth has made it all the way around the sun, the cycle restarts. Okay, before we go, let's go over a couple of quick review questions. What is the current tilt of Earth's axis? A, 22.1 degrees. B, 90 degrees. C, 23.5 degrees. Or D, 24.5 degrees. The correct answer is C, 23.5 degrees. The axial tilt will cycle between 22.1 degrees and 24.5 degrees over a 40,000-year period. When will areas of the Antarctic Circle experience a polar night? A, summer solstice. B, vernal equinox. C, winter solstice. Or D, autumnal equinox. The correct answer is A, summer solstice. During the northern hemisphere summer, the Earth is tilted toward the sun, so the poor South Pole will receive the least amount of sunlight, some parts in darkness for over 24 hours. That's all for